This lesson is cross product. So here we have an example of trying to find the cross product of two vectors. When you set these up, make sure you set it up as matrix. Okay, so matrix, if you remember about matrix, so IJK, so IJK, vector V, which is here, vector W, which is here. So 2, 3, 5, 2, 3, 5. 1, 2, 3, 1, 2, 3. Again, make sure you set it up as matrix. Okay. Now we're trying to find I, J, and K. So to find I, we block up the I column. One more time. To find I, we block out I column. Okay. And then you have 3, 2, 5, 3, which is here. Followed by a minus, always a minus. Now we're looking for J column, so block out the J, 2, 1, 5, 3, which is here. Followed by a plus, find K, so block out the K, 2, 1, 3, 2, which is here. Okay, now cross multiply these, 3 times 3, always minus 2 times 5. Minus because that belongs outside. Repeat that with J. 2 times 3 minus, always minus, 1 times 5 plus 2 times 2 minus 1 times 3. Again, this minus, this minus, this minus has to be there. Okay, and for I, plus J minus K plus, so plus minus plus, so make sure it goes in that pattern. Okay, and then when you do your algebra, it comes out to be negative 1i, negative 1j, positive k. Okay, so when you do the cross product of two vectors, it will come out another vector. Okay, it will create another vectors. Okay, so cross product of two vectors, create another vectors. Okay, create another vector. So here is over here on the graph. Okay, so we want to know what this look like on the graph. Okay, so here's V. V is right here. W, which is this vector right here. And then when you cross product, it comes out another vector, which is in red. Okay, so this is in red. So that's what it looks like in three-dimensional graph. Okay. So again, how do we graph this? So X, Y, Z. So 2, 3, 5. So positive 2, which is here. Y is positive 3, so move up 3. And then Z is 5, so count 5 up. And there's the V vector. Okay. Again, what I have here is just approximation. Okay, it's not the exact graph, but something like that. Okay. So this is this graph. Okay, so when you do cross product of two vectors, you create another vector, which is the one in red. Okay, now the next example, you will repeat that same procedure. Okay, same procedure again, but we want to find out if the vector that we created from cross product, is it perpendicular? Okay, so when we cross product, that's right, cross product of two vectors creating another vector, will this vector perpendicular to U and V? Okay, so same thing again, IJK, so IJK, vector U right here, vector V right here. So find out I by blocking I, so you have negative 2, 3, 1, negative 1. Okay, so block out the I, so block out the I, so negative 2, 1, 3, negative 1, followed by minus, block out the J, so 3, negative 1, 1, and there's a negative 1 here. Okay, followed by plus, and this is K, so block out the K. Okay, so 3, negative 2, negative 1, 3, which is over here. Okay, so same thing, cross multiply, negative 2, negative 1, positive 2, always by a minus, always have a minus, 3 times 1 is positive 3. Repeat that all the way through. Negative 3, 3, negative 1, negative 3, followed by minus, negative 1, 1, negative 1. 3 times 3 is 9, followed by minus, negative and negative gives me positive 2. Okay, so combine when you do your order of operation, comes out to be negative 1i, positive 2i plus 7k. Okay, so again, when you cross product of two vectors, you will create another vector. Now we want to know, is this vector right here perpendicular to this, perpendicular to v? Now another word for perpendicular is orthogonal. Okay, orthogonal is just a fancy word of saying perpendicular. So how do we know that? So we're going to use dot product. Okay, so u dot product w, which is right here, u dot product w. So I with I, j with j, k with k. So 3 times negative 1, negative 3, negative 2 times 2, negative 4, 1 times 7, positive 7, add, subtract gives me 0. So we're all good. So how do I know that it is perpendicular or orthogonal? When the dot product is 0. Okay, when the dot product is 0, it is perpendicular. Now repeat that with VW. Okay, so same thing, I with I, j with j, k with k. So negative 1 times negative 1, positive 1, 3 times 2, 6, negative 1 times 7, negative 7. Add, subtract gives me 0. Okay, so again, when you do the dot product, if it comes out 0 here and here, it is perpendicular or orthogonal. So in this example, u is perpendicular to w, v is also perpendicular to w. Again, how do I know it is orthogonal? When the dot product equals 0. Okay, so how does that look like on the graph? So this example is this graph right here. Okay, so here's u is here, here's v is here. When you cross product of these two vectors, you create another vector, negative 1i plus 2j plus 7k, which is the one in red. And because we show that it equals 0 using the dot product, okay, it equals 0. W is perpendicular to v, which is also perpendicular to u. Okay, so that's what this graph looks like. Again, this example is this graph. Okay, all right, and the last example, we are trying to find the area of a parallelogram, okay, with 4 points. So first thing we need to do is find a vector from point 1 to point 2, find another vector from point 1 to point 3. Okay, so one more time, given 4 points, we want to find the vector from point 1 to point 2. We want to find another vector, point 1 to point 3. That's here. Now to find the vector, all you have to do is just add. Okay, so here we go. So we multiply, and that's it. So I times I. So right here, so 0.1, 0.2, so 0.1, 0.2. So I times I, or x times x. Okay, so x2 times x1. Okay, so one more time. So giving 4 points, we're trying to find two vectors. First vector is from point 1 to point 2. So x2 times, it should be add. Okay, so x2 plus x1, okay, or subtract. Okay, so subtract, because sometimes there's a minus here, so that becomes plus 2. So be very careful of that. So x2, again, we're trying to find the area of a parallelogram using 4 points. So first thing we need to do is find the first vector from point 1 to point 2, and then the second vector point 1 to point 3. So to find the vector, we are going to do x2 subtract x1. Okay, so one more time. x2 subtract x1. That's here. y2 subtract y1. z2 subtract z1. That's here. And if there are extra negative, then that'll become plus. Okay, so one more time. x2 subtract x1 here. y2 subtract y1 here. z2 subtract z1, which is here. And that becomes 3, -2, +1k. So from point 1 to point 2, the vector is this one. Now we need another vector. Repeat that process again. Another vector from point 1 to point 3. So same thing. x1 subtract x2. x2 subtract x1. Okay, so one more time. x2 subtract x1 here. y2 subtract y1 here. z2 subtract z1 here. Okay, one more time. x1 subtract x2 subtract x1 here. y2 subtract y1 here. z2 subtract z1 here. And then do your algebra. Comes out to be -1 plus 3j minus k. Okay, so -1i plus 3j minus k. So these are the two vectors that we need. Again, where did I get this vector from? From point 1, point 2. Where did I get this vector from? Point 1, point 3. Okay, now use these two vectors, cross multiply. Use these two vectors, cross multiply. Now make sure you set it up in matrix. So ijk, first vector here, second vector here. To find the I column, block out the i's. To find the I, block out the I. So -2, 3, 1, -1. To find the j, block out the j. 3, -1, 1, -1 here. And then to find the k, block out the k. So 3, -1, -2, 3 here. Again, make sure it is plus, minus, plus. Okay. And then just cross multiply. -2 times -1, +2, always with the minus. And then 3 times 1 is 3. Okay, where does this negative come from? When you cross multiply, it is always a minus. Okay, so one more time. -2 times -1, +2, followed by a minus. That's by default. And then 3 times 1 is +3. This minus, bring it down. -1 times +3 times -1, -3, followed by a minus. -1 times 1, -1. Okay, bring down the plus. 3 times 3 is 9, followed by minus. -1 times -2 right here, which is +2. So 9 subtract 9, but there's another negative right here. So 9 subtract 2, that gives me +7. This gives me +1, so -3, +1. -3, +1 is -2. Okay, so this is -3. This is +1. -3, +1 is -2, but I also have another negative outside, +2. And then 2 subtract 3, -1. Now once you find that cross product, once you have the cross product, find the magnitude of this. Once you have the cross product, find the magnitude of it. Okay, one more time. Once you have the cross product, find the magnitude of it. So -1 squared, 2 squared, 7 squared, That comes out to be 1, 4, 49. Add them up, which is 54. And you know that 54, the square root of 54, can break it up into square root 9 and 6. Square root 9 is 3. Square root 6 is just square root 6. So this example, the parabola, the area of this parabola, okay, parallelogram, is 3 square root 6. One more time. The area of this parallelogram is 3 square root 6. Okay, so here in this example you have to do 4 steps. The first step is find the vector, first vector from point 0 to 1, the first point to the second point. Find the second vector from the first point to the third point. Okay, use these two vectors, find the cross product. Once you have the cross product, find the magnitude of it, which will become the area of the parallelogram. Okay, so again, this is the answer that we need. This is the answer, the area to this parallelogram. Okay.